For such coding related videos, subscribe to CodewithAG. Hello coders, welcome to CodewithAG. I hope you all are doing great and brushing up your coding skills. I hope my videos are helping you. So here we are meeting again on a medium tag question. The question is minimize XOR. Minimize XOR. So we have given two positive integers num1 and num2. Find the positive integer x such that x has same number of set bits as num2, means same number of ones in its binary form as num2, and the value of x XOR num1 is minimal. Means if we XOR it with num1, it becomes minimal. We get the minimum answer. Note that XOR is a bitwise XOR operation. Return the integer x. The test cases are generated such that x is uniquely determined. Okay. So we have just unique x for every test case. So what's the question? What are the set bits? Set bits are number of ones. Like for 3, it is 1 1. So 2 ones, 2 set bits. Okay. And for XOR, what does XOR operation do? Like we have two numbers 110 or 101. So for the opposite numbers, for the bits which are opposite, it gives 0. It gives 1, and for the same bits it gives 0. So there are these are two different bits. So 1, and these are two same bits, 0. So this can be the answer of XOR. Same bits 0 and different bits 1. So if we have to find any minimal number from XOR, we have to just unset the set bits of the that number. Like if we are given that we have to find such a number which will give whose XOR will give the 0 for this number, whose XOR will get 0. So for 1 we can only take 1, for 0 0, for 0 0. So when we XOR these two numbers, we get 0 0 0, which is the lowest answer. We cannot get minus in this form. Okay. So let's take this question. First question, 3 and 5. So we have to take a number which set bits are equal to set bits of num2. So 5. What is the representation of 5? 1 0 1. Okay. So set bits are 2. We have 2 set bits. So we have to use these 2 set bits to find the minimum number through which 3 XOR that number is very minimum. We don't have to find the minimum number. We have to find that number after which when we XOR this number, we can get the minimum answer. So let's suppose this is 3. 1 1. Decimal representation of this number is 1. And we are given this number is, let's suppose we put it in a variable called count. Okay. We have to use 2 set bits. Okay. Now suppose if you have to find the minimum XOR, first you will unset the MSB or LSB. We will first unset the MSB, because if we unset MSB, it will give us better answer. Let's suppose count was equals to 1. Means we can only have one set bit. So for this question there can be two answers, 1 0 or 0 1. So let's take 1 0 1. Okay, so answer would be 0 1, or for this question 1 1. if we XOR it with this, the answer would be 1 0. This results to 1, this results to 2. So the minimum answer is given by this. What's the difference between this and this? Here we are unsetting the MSB, and here we are unsetting the LSB. We are unsetting the LSB. Okay, so we have, so in this question, in this question our count was equals to 2 number of set bits, and what's the number, what is number, this is 1 Okay, so for this question, firstly we will come across one by one we will unset all the set bits of this number. So for if we don't have count equals to 0, we will unset the MSB present here. So this will be the number. Okay, now count is reduced to 1. Now we will unset the next MSB. Now the count equals to 0. Now count equals to 0. We don't have to change any number. What is this number? 3. What are इनके XOR क्या है हमारे? 0 0. Minimal XOR we have got. And what is the answer of this question? 3. Now for this question, num2 equals to 12. Okay, what's the binary representation of 12? 1 1 0 0. Count equals to 2 because 2 set bits, and num1 equals to 1. Now this is the second case. Of this question. Now the binary representation of 1 is 1. Count is not equals to 0. First we have to unset the first bit. We have to unset this bit, the MSB. Okay, count equals to 1. Okay, now what is going to happen? This is equals to 1. Okay, now unset. Now the set bits are all unset. But still we have got one count. This could not be the answer because it has only one set bit, and we have to find the number of 2 set bit. Now we have to adjust it. Let's suppose the number was 2. 1 0. Okay, so we don't have to adjust it first. Because there is no other space left in this area. No other set bit is left in this area. We will now set the LSB. So the LSB is 1. Okay, now LSB is 1. Now let's check for one more question. This is 1 0 1 0, and the count is 3. Okay, count is 3. So first we will unset the MSB. Okay, count equals to 2. Then another MSB, count equals to 1. This is not considered now for MSB because this is not 1. This is 1. First we will talk about 1 only. Okay, now 1. Now count is equals to 1, but there is no more set bit left. Now what we will do? Now we will find the zeros from the LSB. So first 0 from LSB is this side. It is least significant because if we remove it, it has no significance effect on the number. But if we remove this, it has a significance effect on the number because its place value is higher. So now we will put 1 on this side. Now why I am putting 1 on this side? Because when we do XOR, now this is the only answer. When we do XOR, it will become 1 0 0 1 0. Answer will be 1. It will give us the minimal XOR. We don't have to find the minimal number, but it will give us the minimal XOR. But if I have done not this, if I've set this bit, if I've set this bit, so this would be 0 and this would be 1. It would have given me answer 4, which is not true. It is not minimal. We have found the minimal, which is 1. Okay, so we have to take this answer, which is 1 0 1 1, which is 8 plus 2 10 plus 11. Okay, so this is the question. This is our question. Now we will code for it. First of all, we will understand the algorithm. For a better question, for a better example, let's suppose num1 equals to 25 and num2 equals to 72. Okay, now num2, if we look at the set bits, num2 set bits are only 2. I will explain you the algorithm here. We will find first all the set bits. So these are 2 set bits. Now we will make a vector and put all the digits of this representation in this vector. So this would be, if we represent it, it will be 1 0 0 1 and 1. Okay, now we will check it. This is the it means the number is 1 1 0 0 1. This is actually the number, not this. This is the reverse form. This is This is 16, this is 8, and this is 1. 16 plus 8, 24, plus 1, 25. My number is correct. Okay. So the vector is 1 0 0 1 1. This is our vector. Okay. Now we will make another vector. Okay. Now what will be the size of the vector? We will have to check what is the size of v and the count. Whoever is the maximum value. Now vector size of vector is 1 2 3 4 5 and 2, which is maximum 5. So we will make a vector of 5. 1 2 3 4. Okay, and mark the values at 0. Okay, this is our vector. Now what we will do, we will start counting. Is the count equals to 0? No. What we will do, we will check the MSB, the highest MSB present here. MSB present is, for 1 is this one. We have put 1 here. Okay, now the count is decreased. Now count is not equals to 0. We have to find the MSB, which is 1. Okay, so here also we mark 1. Now the count equals to 0. So the answer is 16 plus 8, 24. This is our answer. Now if we have if not got fully 0, if we have got like we have 3 chances more, what will be the answer? Now we will find another MSB having 1 bit. Okay, now if I have got one more count, what would I have done? I would have to find the LSB of 0, because all the set bits are gone. Only unset bits are there. So 1 and then 1. This will be the order. We will traverse all the bits in this array and find the minimum value, which can find out the minimum XOR. Okay, but this would be the case if we have to make a number of 5 set bits. We have just to make number of 2 set bits, which is 24. I hope this is clear. Okay, now start with the question. First we will mark a variable called count. What is this variable doing? It is counting the set bits of num2. Okay, so we will count the set bits of num2. We will check if the number is odd or even. If the number is odd, means the last bit is 1. So we have found that last bit is 1, so we will increase count. Okay. Else we have to do nothing, because for the unset bits we have to find nothing. And what's how will we increment the loop? It is num2 right shift, num2 equals to num2 right shift 1. How it is working, let me show you. For 5 count equals to 0. If this number odd, 5 is odd, count is 1. We will left shift it. So after left shifting, it will become 1 0, which is 2, which is also we get when we divide it by 2. Okay. Now is this number odd? No, it is not odd. We have to do nothing. Now we have to also left shift it. We will get 1, which is also we get by dividing by 2. Okay. Now is this number odd? Yes, it is odd. Count is equals to 2. Now we will left shift it. We get 0. The loop is over. So we have got 2 set bits in the number, which are 2 set bits only. Okay. This is for left shift, and left shift also does division by 2, and right shift does multiplication by 2. Okay. So this is a basic thing. Okay. Now we will make a vector for storing all the bits of number. We will just copy this loop. This loop is fine. Okay. But what we have to do, we have to first check if num1, if it is odd, first we have to correct it. If it is odd, then we have to push 1 in the vector, else we have to push 0 in the vector. Okay. And after the loop is completed, we will right shift the number by 1. This is our question. Now we will take a number k. Why I am taking the number k? Just to determine the size of the answer array, which I have to found. Okay. So I can also make a maximum function, but maximum function will not work here. So if vector of this size is greater than count, so k will be equals to vector size. Else what is happening? Else k equals to count. Okay. Now we will make another vector. We will make another vector named a, whose size is equals to k. It has the maximum of v of size and count, and marked all 0. Okay. Now firstly we will look at all the MSB of unset bits. We will find all the MSB of unset bits. 0 and I minus. We will check if at this bit it is set or not, and it is set and not, and if count is existing here. If count is not existing, we don't have to forward this loop. Okay. If both of these conditions are true, we will mark a of at that index a of this vector a as 1. Okay, and we will reduce our count because we have used one of the set bit. We have used one of the set bit. Okay, now this will when this loop will be over, there can be a possibility that count is not finally over. Okay, so if count is existing, now why I was taking the max of the value, I was taking the max of the value because the case could be like 5 5 and 1, so count equals to 2, and here vector was only 1, size is only 1. Okay, so we could only set it here. Now we have to put another set value somewhere else. So for that I have to take another box. So we will use vector. We will already assign such value to the vector. We have to take the maximum size possible for the vector. Okay, now here we will traverse from LSB to MSB. Here we are traversing from MSB to LSB. Now here we will traverse from LSB to MSB and find all the unset bits. All the unset bits. This array will just traverse a vector. Now we will check if at that index the value is 0 and count is existing or not. If it is happening, then we will mark at that vector 1 and count will be decreased. Okay, now this loop is completed. Now we will take our answer variable and we will traverse the whole vector and find out the value. So we will traverse the whole vector from MSB to LSB and find. Now let's suppose our number is this 100. This is a representation of 4. Firstly, we will take how to find from this number that the number is 4. Now for this, firstly we will take answer equals to 0. Okay, we will traverse the MSB. Firstly we will multiply the answer with 2. So 0 into 2 equals to 0. 2 plus this number, 0 plus this number, it is 1. So answer equals to 1 from this bit. Okay, now coming to this bit, we will multiply the number with 2. So this become 2. 2 plus 0 equals to 2. Okay, now for this bit, firstly we will multiply it by 2. So 2 into 2 equals to 4. 4 plus 0 equals to 4. So the answer is 4. We have got through this way. We will traverse from MSB to LSB. What we will do, we will first multiply it with 0, with 2, multiply it with 2. Okay, and then we will add that value of index and return our answer. We can submit it and check if the value is correct or not. Some errors is coming. I hope I haven't done any error. One minute. I think I've just done this. First of all, let me check. Okay, I have put this -1 here, so I don't need this. Now let's submit it. Okay, running perfectly well. So I hope you all have got the question correctly. If you like the question, please give us a thumbs up. Please like, subscribe, and share to the video. And please put down in the comment section if you have any doubts. I will be happy to read the comments. Thank you.